Hi, everybody. My name is Nicholas Beaudois. I'm the Director of AI Programs at Caltech's Center for Technology and Management Education. It's our premier professional studies institute. And welcome to Making AI Possible. This is a new podcast from Caltech CTME where we kind of connect the brilliance of different academic research with the real world challenges of industry. If you do have a chance, write into the message where you're calling in from, maybe what industry you're from, and then any questions you have throughout this conversation with Professor Giaxari. So in this podcast, we're going to take you behind the scenes of Caltech's leading professors, researchers, and really innovators who are helping shape this world of AI. From robotics to generative AI models, autonomous systems, responsible AI, these are all different breakthroughs that are happening in different labs around campus and really becoming game changers for business and technology and beyond. So whether if you're an AI enthusiast, if you're a tech leader, you're just really curious about how cutting edge science is applied to industry, this is the right place. So let's dive in. Today, I'm really excited to introduce and have Professor Georgia Giaxari join us from Caltech. She is a researcher and really an influential mind when it comes to everything computer vision and 3D deep learning. Professor Giaxari's work centers around understanding the four-dimensional world, if you will, but by using less data and less compute than our current champion models and techniques. So in a sentence, I once heard her say, teaching machines to see like humans do. So Professor Giaxari has a PhD in AI from UC Berkeley, has spent really the last 7 years before joining Caltech's faculty at Facebook's AI research lab, or Meta, working on cutting edge research around Mask CNN, open source platforms around PyTorch 3D and Detectron, and contributing different breakthroughs around computer science. And so she has joined in 2023 and has gained accolades while on campus. So Professor Giaxari, I will let you do your own renowned introduction, hitting on the main points, and we'll get started from there.
Great. So first of all, Nick, just call me Georgia. I think that's good.
Noted.
Good. Yeah, thank you for having me. It's great to be here. And I'm happy to engage with the audience and answer any questions. Just throw any hot takes you have. I will answer all of those. Yes, so I joined Caltech 2 years ago. To focus more on AI for important problems. At that point in time, and actually for many years before that, a lot of us had seen and understood that AI is going to play a major role across tech and science. It's an innovative way and revolutionary way of understanding the world through data and observations and making sense of them. And we have so many observations that we're yet to understand as a species, honestly. It would go a long ways if we did. And AI is a fantastic tool for that, but we still have to do a lot of work to direct it towards the right applications and for us to see the results.
Right. In one of your talks in 2024, I think it was on This Week in ML, during your introductory interview to the Caltech community, actually, no, this was actually internal. You said that you had this YOLO life moment where you said you wanted to make a switch from academia or from industry to academia. Can you explain a little bit about that?
Yeah, yes, of course, I'm very happy to. It's a very sort of loaded topic because there are so many axes and directions, but maybe I'll focus on a couple and we'll see where it takes us. So, as I said, after I graduated from Berkeley in 2016, that was at a time, just to give you context, the first sort of big result in AI and deep learning, like the first result. There were people working in deep learning for many years and decades, like Yann LeCun, Jeff Hinton, these people were working in deep learning. But one of the big results happened actually around 2012, 2014 with the AlexNet moment. And that was in the mid stage of my PhD. It was 3 years in at the time. And so it was a revolution. I remember we came to our office in Berkeley and we're staring at our screens and we're all looking at each other. There were people from other cubicles standing up. We're all staring at each other. That was 2013. And since then, it's been a tremendous sort of journey of learning new skills. Now, you need to understand 2013, before that, we were doing completely different things. So overnight, we trained ourselves to understand a lot of the technology behind it, master it. We had to learn new tools. We had to understand how to work with GPUs. At the point, we were only it was everything was CPU. Even a Google, everything was CPU at the time. So we had to learn and teach ourselves all of these new skill sets and understand and kind of envision what it would be like in the future. So 2016, I graduated, and I felt like it was sort of a pivotal time, and I needed to explore more. And I was definitely in the exploit phase and not in the explore phase. I wanted to just become an expert in deep learning. And so I joined industry for that exact reason. It was a fantastic time. We were given a lot of freedom to work on the things. And I thank kind of the CEO for that, for establishing a lab that would be pure research, no attachment to products, and no obligations to work on products.
And just to clarify, CEO, we're talking Mark Zuckerberg, right?
Yes, Mark Zuckerberg.
Okay.
So I mean, he gave the green light for a research lab to exist, an AI research lab. At the time, the company had no use of AI. So he had the foresight to build an AI research lab in a company without it being tied to any products in the immediate future. And so there was a fantastic time where we got to explore a lot of the things in deep learning and AI, and we advanced the state of the art tremendously. But as I said, YOLO, you only live once. After 6 years, I realized that I was ready for a new journey. I missed mentoring students. I missed teaching. I also missed being challenged more with a different set of applications in AI, not just pure sort of sticking to like the pure ML and the pure like advancing the state of the art for the sake of advancing the state of the art. At some point, you get to think, what is that state of the art going to do? What problems is it going to solve? And these are the challenges that I was ready to have. And this is when I decided to transition to academia.
Excellent. And one of the points we were talking about before, and in the numerous accolades that you've accomplished in your career, the Hertz Fellowship at Caltech is one of them. Can you explain to our listeners what the Hertz Fellowship is and what that allows researchers to do?
Yeah, absolutely. So this is a program that is established at Caltech. It's given to a faculty all around Caltech from from actually all of the divisions. We're talking about physics and math, GPS, which is our geo, like people studying earthquakes and the earth and all of that stuff. I need to up my game in my acronyms. EAS, which is that where we are at here, which is engineering and applied sciences, as well as HSS, which are our humanities and our economists. And so it brings all of these people together. And that's fantastic because I really can't name another institution where on a biweekly or monthly basis, all of these people, like a selection from our faculty, like at Caltech, across all disciplines of technology and engineering coming together and get to discuss. And we exchange ideas, we give talks about our work, and we're able to sort of connect on problems that otherwise we would not be exposed to because simply we're so busy. And so actually a few collaborations have started that way. Through that program, I'm working with Hannah Druckenmiller, who is an environmental economist in HSS. We're working on a fantastic problem on trying to understand how humans through a lot of the work that we do on Earth, converting land to residential areas or removing wetlands and building things on top of it, how that has impact and effect on human lives on a time span of like decades after the work was done. So, and we do this, you need to understand no one can predict that, but now we have data and we want to use this data to be able to build a very good model that can actually predict what the consequences will be.
Interesting. And how do you feel with being able to have students participate in this? What impact does that have on people who come to Caltech, be it for undergraduate, graduate studies, or even postdoctoral researchers being able to work with you? Are they able to participate in this? Does the fellowships allow that type of participation?
Of course, I mean, our students do all the work. Absolutely. So students are participating. So we have grad students who are working on this with us. And as we speak, we We do have grad students on this exact project. And even if you don't work exactly on this project, you're not the person leading the development of these models, you actually get exposed to these problems. And if you're a student here, you will hear me talk about this. And that in itself has impact because it broadens your mind, it broadens your horizon as to what data science and what AI can do for all of these applications beyond the typical things that you see on Twitter and on the internet and like the New York Times likes to cover.
Yeah, that's very true. A lot of it's hard to determine what's hype from recent articles and, in the press and
Oh,
what's vaporware.
don't get me started.
I'm sure that could be a whole nother series in itself. So I'd love to bring it back to some of your key research that you did while you're at Meta at FAIR. You worked heavily in kind of explaining this gap between 2D images and the 3D world that we listen in. A lot of the folks listening in are from, be it industry or maybe a non-technical background. What does this mean? Can you explain like why taking a flat image and actually understanding a scene in depth is important to people in industry?
Absolutely. Yes, I'm very happy to explain. And maybe I'll start a little bit by describing maybe or having you, all of you listening here today, think about how you are perceiving the world and how you are acting in it. And so, okay, right now we're having a very 2D discussions. I see you on my screen, you see me on your screen. But let's imagine what all the steps that you took to get to your office today. You have your eyes, you have light coming in. You have biologically, you're equipped with a lot of great tools, like your cells and your retina and all of those things that transform light, is getting propagated through your brain, and your brain actually allows you to take actions in the world. But what that means is that you, from simply the light that you're seeing, which now you can, let's draw the parallel to the image, you're actually to infer a lot of things about the 3D world. You're perceiving how far objects are. When you're driving your car, you're understanding how fast everything is coming at you or if things are moving away. All of this understanding actually happens in 3D. It does not happen in 2D. And so that is exactly what allows you to take the next action under a lot of criteria, some of them like safety, but also gets you to your goal faster. And that ability for us to actually take in light and then convert it into something that we don't quite understand from a neuroscience, like vision science and neurological perspective. But we do know that we are perceiving the world in 3D, and that allows us to act in this world. And so this is exactly, so that was a very like kind of
No, that was perfect. That was
maybe
perfect.
explanation of how things work. I'm sure if there's anyone like that's from neuroscience and vision science, are probably like, oh, that was not very accurate. Absolutely.
Wrong
But
audience, wrong audience. Go somewhere else.
but I try to give a broad overview. We have some understanding of, by the way, just from the neuroscience perspective of how we are perceiving. We know kind of roughly where things are, like our vision systems like kind of back there, but we don't exactly know the processes that happen exactly that transform light into meaningful representations. And so this is exactly what I'm trying to study, but taking it from a more computational approach. I have images as input because this is the means with which we are seeing and capturing the world. Our phones or the cameras in your car, cameras and robots, they capture the world in 2D, and these are RGB images. Occasionally you might have some depth, but it's going to be sparse and inaccurate. And I want to be able to transform that input, that image, into a 3D representation that will allow robots to act in a more general way so that we don't have to train so much, and in a safe way so that you can take decisions even if you're not sure of what you're perceiving, but you have enough information to make safe decisions.
Excellent. Now, moving kind of, you've talked a little bit about 2011, 2012 with AlexNet and transcendence of ImageNet as being this great robust area to be able to train. How has the transformer-based model, circa 2017, has it had that same monumental moment that it has for computer vision as it did for NLP?
Oh, absolutely, of course. It has. So the transformer is just an architecture. A lot of people try to draw parallels with how the human processes the light, and if there are any parallels to how our computers are doing that sort of information processing. So it's a neural architecture. It's a deep learning model that has what I like to call very minimal inductive biases. So in computer vision, before the transformer, we had convolutional neural networks which are basically learned filters that process the image row by row and transform it to another representation that's then being processed again by another convolution. That has the inductive bias that you have a little filter that you're applying to the image in a cascade fashion. So the inductive bias here is the locality. Transformers don't have an inductive bias. The model is free to draw into connections from any pixel to any other pixel. In language, that means from any word to any other word in your input without constraining it whatsoever. That model has shown, just like in NLP, has shown that it has some of the best scaling behavior. Scaling behavior means that the model performance increases as we feed in more data and as we increase the model capacity. This was not exactly the case in CNNs. We were actually getting a plateau as we were giving it more data or increasing the model, but the transformer model has actually shown much better, much more promising scaling behavior, which is why it also has had tremendous impact in computer vision.
So we see a tremendous, and maybe this kind of goes to some of the hype around benchmarking. And I know, some of your excitement for, the marginal increases and using such robust GPUs. I think one of the lines from one of the This Week in Machine Learning podcasts from a couple of years ago was melting the Arctic to get 1% better usage. Are benchmarks still applicable to industry, or do we need to move somewhere else?
Benchmarks are absolutely applicable to industry. And I would say that right now our benchmark game is lacking our modeling game, or is behind significantly. So the thing to sort of the way that I also tell my students on how to think about benchmarks is that they're dynamic. They're like organisms. A benchmark that is left the same for many years has absolutely no value. You need to keep thinking and keep changing your benchmarks to make sure that we're testing and that we're evaluating the right properties. And so it's something that industry is very well aware of, that they also need better benchmarks. Actually, I would say that coming up with great benchmarks is probably more difficult than training a trillion parameter model at this point. This is also where, and have many feelings about this, but this is also where a lot of the synergy between academia and industry is right now, is a lot of sort of common interest in developing good benchmarks that will benefit both. And myself, I'm also very interested in this, especially from the 3D perspective. A lot of these fantastic models that we're seeing today actually are lacking in 3D understanding and perception. You ask it what is further behind or what is another thing, and things are kind of going like that. So I'm really sort of pushing towards that direction and trying to come up with benchmarks that will also inform our methods, of course.
So I'm going to kind of combine some of the questions that I'm hearing in the chat thread. Say, for example, you work for a manufacturer. This could be a automaker, like maybe the Mercedes or Honda or Tesla, and they're using computer vision to look for defects, say, like on a process line. How do you manage to take a model that might have PhD level understanding of the world but doesn't know your business? How do you take a vision-based model and have it really understand your domain data, be it in manufacturing or really wherever?
Well, that's a great question. It's a great question. I don't have a profound answer, but maybe I can kind of describe it. If I did,
Also, full disclosure, that question was never shared beforehand, so you're absolutely on the spot.
Oh, no, absolutely. I mean, I love these questions. So maybe to take a step back to understand a little bit how these models are trained. Something that I keep telling everyone is that these models are not black magic, nor magic. The data that you give it in is what you're getting out. So these models, the ones that you know from OpenAI, Meta, Llama models, the Gemini models, the Claude from Anthropic, they're all trained on vast amounts of data. This data is common data, it's data that you can find on the internet. A caveat there, they're also collecting more specialized data pertaining to various domains that might not be as common in on the web. But let's largely the vast majority of it comes from the internet. That means that these models, the knowledge that they have is knowledge that comes from the internet. This is what I like to call like common knowledge, like common sense. Imagine a person that has subsumed all of Wikipedia and knows all of Wikipedia.
I'm sure some of our listeners are one of those people.
Okay, great. So you're probably a repository of great common knowledge. You're probably also very good at trivia, which is a hobby of a bunch of faculty of ours. And so if you are, please join us in your Pasadena. We're looking for more. And so these models know a lot about the world in its most common sort of form, like the things that we see around us. Now, you're talking about an application in manufacturing, which becomes a very specialized domain. So the question is, how do we actually adapt these models to be able to work there? And you kind of want to combine a little bit of the common sense and the common knowledge that these models have. You don't want to have to undo that because it's very important, but you want to endow these models with more specialty skills. And so how to do that is actually kind of an open research topic in the sense that the naive, straightforward idea is to just collect some data from your domain and then maybe fine tune the model. But what that will do is like the model is likely going to forget its past and to adapt to its domain, and that's not quite desirable. Another thing is to actually prompt the model with the right data and hope that somewhere in its knowledge graph, it has some knowledge about that specific domain. All you have to do is have it focused there. That is only if you have any hope that the model had seen something about your application, about that application during training. But largely, how to adapt these models to become specialized, but maintain their strength in common sense reasoning is a little bit sort of an open question.
That's a really good explanation. Thank you. I think we got a couple of the questions out of the way there. Um, in terms of having a model become an expert of your own domain. So if you're working in a manufacturing plant, is there any role for computer vision for synthetic data generation as it has been successful with other LLM based applications? Is that playing a role anywhere?
We would like it for it to be. Yeah, so that's a great question. So you're referring to large language models where we know that are actually at this point trained with their own outputs, which sounds kind of ridiculous, but it actually isn't. And it's actually fantastic. It's like self-learning, right? So they predict some outputs, and then you have some mechanism of cleaning out those outputs, keeping the very high quality answers, outputs from these models, and feeding back in to train the model. Is there room for this in computer vision? Absolutely. But I think that we need for our models to get a little bit better. Computer vision is a little bit behind the computer vision applications, either generative modeling or even reasoning in vision space, like thinking in vision space, is it's a little bit behind language. And I do think that we'll get to this point, though. It's going to take a couple more years.
In previous interviews, you've talked about your excitement of CLIP. And again, this was a couple of years ago that I went into the archives. Are there any papers recently that have gotten you as excited as you did when you were mentioning CLIP?
Yes. Oh, yes, absolutely. They have. I wouldn't say that it's quite the like oh wow moment of CLIP because that was truly sort of phenomenal. It was a problem
Yeah.
that was completely untouched. But I do have similar moments, maybe a little bit like two orders of magnitude down.
Yeah, and maybe you can even touch on, kind of the origins of CLIP and what it's done for industry, for those that might not be familiar with it.
Yeah, so CLIP is a model that takes in an image and project it to some other space. So you map an image to a vector, and it turns out that this vector is sort of this process of mapping is so good that you can use this vector to actually understand a lot about visual concepts. So you can retrieve it groups semantic objects, like objects that belong to the same semantic class together, which is great. It also allows you it also groups and allows it predicts attributes, like a red carrot doesn't that doesn't exist, but the model has that ability to actually understand what that is and bring together other instances that look exactly like other red carrots in your data set, no matter how rare. I'm trying to explain this in the most broad terms possible. But this was a problem that, again, if you see what we were doing before then, we were trying to improve object classification, like predicting a cat versus a dog or a carrot versus an apple. And that was a very important problem that we couldn't make progress in. But we're also, as a community, kind of stuck in these like specific categories that was like the closed world, what we call. And what CLIP did is said, screw the closed world, open it up, learn through a vast variety of image and text pairs in order to learn that embedding that will allow you to actually classify a cat versus a dog, or a carrot versus an apple, or a red carrot versus a green carrot. And use language in a free form as the medium to actually learn these representations. And it turns out that such a device allows you to improve all of these problems and generalize zero shot to even new categories that you might have never seen before. And so that was the exciting moment. For CLIP, it was like a paradigm shift in how we were solving and how thousands of people were solving a problem before. And so these are like the oh wow moments in machine learning and AI.
So what are some of the newer oh wow moments that you're seeing?
I think for me the oh wow moment was definitely the oh 01, oh 03 moments, the reasoning moments from OpenAI. This was mostly in language so far, seeing sort of a large language model reason through very complex problems and actually outputting intermediate steps. A lot of people were really unhappy, are unhappy with AI because it's not interpretable. You don't understand how the model came up with the answer, but now you actually get to see this intermediate steps, and you actually get to see how the model formed its final decision, and you can even contest some of its intermediate steps and say, hey, I think that in the first step you're actually wrong, and the model can go back and revise it. I mean,
Yeah.
wow. I don't know, some of that reasoning is like truly like better than humans. So that was definitely like a wow moment, but that's in language. In vision, I would say for me, some of the wow moments are in 3D and 3D reconstruction. There has been a step change in performance going from image to 3D shapes in the last 2 years. It's less of a sort of paradigm shift, I would say, but still the progress in results is fantastic there.
Excellent. So, as we've already were told, we have a lot of industry leaders and folks who work in professional studies from in this podcast. How do they bring cutting edge AI research into their products um, while listening to kind of I don't know, what's being echoed in academia, what's some of the top research papers? How do you bridge that gap? Is there any advice that you give, any nuggets of wisdom to folks in industry?
Hire very strong engineers and researchers. That's the only advice I have, in the sense that uh, there is a lot of demand for even exploring AI for applications where it might not be obvious how AI can help you. Um, and I think that's very awesome. And I think that I'm really supportive of that. But it will only be delivered, and you only do a good job in exploration if you hire people with the right technical background and the right skills to solve open problems. And I think that we're going to see that a lot in moving forward in AI, where we're going to actually have a demand for these more skilled researchers that know how to work with large models very well and efficiently. They know their PyTorch, they know their even lower level than that, actually. being able to like all the software stack from infra to inference and test time compute, but also solve open problems. And kind of this is our job as faculty here at Caltech, like now with my, faculty hat and now researcher hat, is actually to train that next generation of folks that are
So
able to
this next question dovetails very well into that is how do folks in industry hire positions? And your side, how do you train students to have tools? Because the paradigm has shifted. Machine learning life cycles is about the end product being an API to ship. Now the starting point is an API, and now it's all about the orchestration and hard software engineering skills. What skills do you hope students come out with Caltech that industry can pick up on?
I mean, I just want to say, just historically, everything that has happened in AI has come from PhDs. Of course, there are exceptions to this rule, like Alec Radford, like the first author of CLIP and GPT, actually had no PhD. But I don't want to talk about exceptions. Something that's one exception is like really high up there.
No edge cases.
I devote 10 minutes about him in my lecture. All the professors. So there are exceptions to the rule, but I want to say that the majority of AI progress has happened from PhDs because of these, mostly because of the ability to pick up anything very quickly, anything you don't know. I just told you 2013, deep learning came up. Overnight, we learned a new skill set right away. But also the ability to solve open problems. This is not a PSET. This is not the homework assignment that you get in undergrad, right? You're faced with a problem that you don't know the solution of, and now you have to think, how am I going to even explore directions that are the most promising that can get me to a solution? And that is a mindset that you're being taught in grad school. And I think that the same will continue. I mean, my students' have to be very strong engineers, and they know that in order to even get to exploring their solutions. So we are training large models. We are very much aware of all the operational stack, like infra, as well as inference that needs to happen in research. And that's where they spend the 8 hours a day. I try to have them have no meetings, no other distractions, so they can focus on their craft.
Wonderful. That sounds like a phenomenal environment to be in as a researcher. So your students are probably
out there, but like we have
I don't know. I heard 8 hours. That might be an undermount.
No comment.
By the way, all labor laws in California are being followed. Look at the small text. Okay, one of my favorite terms of a podcast I really like on vanishing gradients, Hugo Brown Anderson, he talks about how companies have POC purgatory. Essentially, you're stuck in demo land. I think we've all seen the nice little RAG demo that talks to your internal documents. And many companies are still struggling to implement that. But then you go to these large conferences that many of the cloud-based hyperscalers are talking about, and it's agents from the rooftops. How do you talk to students or companies or researchers who say, I'm looking at this shiny object that could be very vaporware, but I'm down here? How do you kind of have a coming to your respective Jesus moment with companies to say that maybe you need to take baby steps?
It's a great question. I don't have an answer for you. I do think that right now there's a little bit of I don't know if that addresses your question, but right now there is an overconfidence in what API calls can do to a lot of products. I think that we're going to see a limit there right away. I think that there isn't a blanket answer to this, because it truly depends on the company and the product that they're serving. Is your product facing, is it interfacing with actual users, like with customers, or is it interfacing with other machines and other sort of so you don't need for it to take into account emotions and reactions and even accents, and like people speaking in a different way. So it's kind of, I don't have a profound answer. I would say, once again, you need a very good CTO.
I think that's the answer right there. I'll take it. I'll take it. Um, so again, our audience mainly industry professionals. From your perspective, what makes this moment in AI exciting for someone who might be coming out of research, maybe one of your students, and joining someone in the audience's company as that PhD researcher and engineer you're talking about?
Um, I mean, which happens all the time. A lot of our students go to industry. I mean, the great thing with the field that we're in is that you have both paths open, like industry or academia, with a big salary gap. Um, uh, so I think that there's two things. So you either hire students and they get to like PhDs and they get to work sort of on the same direction that they were working on before. Like if you hire my students, they'll have a solid expertise in computer vision and building perception models. So you really leverage that, the fact that they were trained for 5 years in a very sort of rigorous and very deep and tech-oriented field, and are able to devise solutions. But you're also gaining people that have learned how to solve problems again. So even if the topic and the task is not computer vision related, you get people that actually know how to approach problems that seem very difficult. And this is sort of why PhD like researchers like coming out of PhD programs are actually so invaluable, is because they have that skill set. So it's not about sort of executing tasks and achieving milestones. It's actually about creating that roadmap. It's like, how do I get from A to Z, and creating
Mm-hmm.
intermediate steps.
Is there any classes that you wish were taught at the undergraduate level at maybe public universities or other non-engineering schools that could help with that toolkit?
Um, uh, Frankly, you have to bang your head against the wall multiple times to learn. It's one of those things that you really can't teach in a classroom. You actually have to be faced with a problem, like not knowing what to do, come close to like crashing in order to like come back up again. So I don't have, it's not, I don't think that it's something that can be taught in a class in like 2.5 months.
So you can't vibe code your way through this, is what you're saying.
Absolutely not. You can't vibe code your way through most of the things that we do. Um, Vibe coding is like, it's at a different level, I would say.
Now, how can we leverage AI for coding tasks? Whereas, say for in the past, if I anytime I wanted to run something basic like an sklearn workflow, I Stack Overflowed it. Can we use AI coding and AI generation to allow us to template and move from there? What would be your recommendation if you're just learning kind of the data science lifecycle?
Yeah, it's a great question. So I'm going to say a few things. If you're learning how to code, I would really discourage you from using AI coding in a blind way. So it's very likely that if you want to have a successful career as a software engineer, you're going to be solving more and more difficult problems where AI is not gonna help you. And so one danger with relying too much on AI coding assistance is that it detracts your ability to actually
Yeah.
create code that solves a problem from scratch, which is something that you will have to do eventually. Now, if you don't have like aspirations and you just want to like get through your 9 to 5 very quickly, by
Like
all
if you
means,
don't have aspirations in life.
in life, just like, which is totally fine. And I commend you for that. You probably are very happy if that's who you are. Then yes, please like use AI coding assistance all the way through. They'll likely make your life very happy, and they'll speed up your production of code. But we see this all the time. Maybe anecdotally, I will mention like Jupyter Notebooks, which was actually, it's not an AI coding assistant, but it was a very helpful interface to run code very quickly.
Mm-hmm.
And My partner is actually part of the scientific Python ecosystem. We're actually also very good friends with Fernando, who created Jupyter Notebooks. And all together, we have actually discussed how Jupyter Notebooks have led to a generation of students that don't understand the workflow of computing, because you have cells and then you can go up in cells and you expect that, oh, I'm going to run a cell above it and then everything should, but that's not how it is. Everything actually runs sequentially and linearly. And that is something that you only understand if you write code as in a file, the way that it's being executed. While Jupyter Notebooks, for instance, kind of disrupt that, and that leads to a misunderstanding of computational workflows. So this is very similar to AI assistants, I would say. But now coming back to, let's say that you are a very good engineer and you kind of don't want to be stuck with the mundane problems, then yes. Just to mention an example with my students here, how they're using AI code. So their AI assistants are not, coding assistants are not helpful for them because we're writing code to solve a problem that was never solved before. So it's not going to do anything for them. However, they run into a lot of errors and a lot of sort of bugs that their code might have, especially when you're running CUDA code, where some of the stack traces are kind of, they don't tell you exactly where the problem is. They're kind of like, they say, I sense an error somewhere. It's somewhere around here. Now, this is a great example where you can search on the web. Stack Overflow is not going to give you something. And they actually use a lot of coding assistants to help them, give them hypotheses about where the error might be. So there are all these different ways. And of course, we're all embracing that, but always with a caveat that if you rely on it too much, you might lose your ability to write code that is not reflected on these models and their abilities.
That's interesting because Google's Vertex AI, AWS's SageMaker, they've all kind of followed this Jupyter Notebook-esque type of infrastructure with their pipelining. Is there a danger to that in industry on relying on that? And maybe if you have any anecdotes of where you've seen that trip up.
I've never seen any of that be used in industry as of now. I think for that reason, I would say that even in industry at Meta, our infra was even more rigid than that. And it was very, actually, in order to commit code, and which is something that I really like enough taking here, like I'm forcing students here, in order for code to actually land in like the repository of a company, it goes through really, really, really thorough code reviews. And unit tests that you need to write to make sure that your code doesn't fail. And I would say it's very rigid. But the process of learning how to write good code, and this is a skill set that I'm seeing, like that's a skill set that's declining, unfortunately, is that's the impact that a lot of these tools might have.
Is there any hope for the DevOps community to help jump in and save some of that by implementing lessons we learned in ML ops to what AI ops or LLM ops or whatever we're calling it?
Yeah, it would be fantastic. I would love that. I think that there are a lot of great lessons from how the ML community has built these tools that have abstracted away a lot of the mundane problems. So they've created this beautiful interface, layer and level of abstraction that allows you to develop very quickly and solidly. And I wish, and not even DevOps, I also wish that our physicist friends and our astro friends and our chemist friends actually did something very similar, so that they could reduce the barrier of entry and have more people kind of like experiment and research in these disciplines. So same for DevOps. Also would love something like that for sysadmin purposes, managing our compute clusters. Oh my God, that is a skill. We can't find enough people to do that.
So and maybe look at Caltech's career services website if there's any postings for anybody in the compute services industry there. All right, putting on the cap of responsible AI in industry, working in computer vision, tremendous amount of bias if you're pulling essentially the internet into your models. How do you deal with bias? So, is that on the side of the data collectors or is that on the side of the model generators?
All of it. There's bias through the whole process. There's bias in the data themselves. There's bias in the collection of the data. There's bias in the modeling and how we model, because they're all modeled by humans. So there's bias in all of it. And that's something that we're not gonna get rid of. anytime soon. The only best way is to make sure that we have ways to assess that bias and have enough incentive to mitigate the bias.
And what would an incentive? And maybe this is going over to the HHS department where the humanities live, but what policy incentives can you put in there?
So generally when your models are biased, so the biggest incentive is that you want to mitigate that because you want to improve your model. So when a model is biased, it means that it will also not work very well. And so you will lose users, and that means that you lose profit. And so you want to make sure that there is no bias for that reason. Maybe that's like the best case scenario, how the incentive to mitigate bias, as in you want to attract more users. And that's one. Now, there are if your models are making decisions that are against, I don't know, like let's say minorities, where that incentive might kind of not be as strong anymore, then that is where society should be coming in. And this is where policy and regulation should be coming in. And I'm going to leave it at that.
Noted. Got it. All right. Well, I've intermingled a lot of the questions that we've heard. I tried not to make it as static as, here's question A, B, and C. One final question before we let you go to your busy schedule. I have to pull up my notes because I want to kind of read where the background of this. You gave a talk. It was kind of this AI on the big screen at Caltech. You had a handful of different AI visionaries from faculty. And you were talking about how AI is used in sci-fi and where it gets it right, where it gets it wrong. And one of the questions, this is kind of a fun question, was asked, create an AI inspired film. And trying to jog your memory here, you had said, it's going to be a comedy in the 90s during the grunge era in Seattle, kind of akin to the Riot Girl movement, where you got like a cadre of young women who can foresee ChatGPT and AI, and they have an opportunity to kind of correct any injustices before they happen. One of the disclosures you gave to a very large audience was anyone can take the rights to this. So one, I want to know, are those rights still available or have you rescinded?
I can't believe I said that. Can I take it back? Does that work?
Here's the opportunity to take it all back.
I take it all back.
Would you change
rights reserved.
Would you change the movie script?
Actually, no, I don't. I didn't quite remember all these details, and then now you get the script. I was like, oh man, that sounds so good.
It was also, as you said, very early in the morning, and there was either a lack or some had more caffeine.
It was a noon, I want to say, but it was a Saturday. So
hey, that's morning for some of us, Georgia.
Exactly. That sounds like a great movie, actually. I often think, oh man, I wish I knew, like I could see a little bit of the future so that I could make some like wise financial decisions, like invest in NVIDIA in 2010.
Yeah, that's what I was going to say too.
So I think that I would really stick to that movie, I would say. I think that sounds great. And
do we have any actresses or actors in mind?
Oh, that's a great question. I would definitely love to have Florence Pugh. Is that how to pronounce? I think that she mine. I feel like she would be like the main, like she's super rock and roll anyways, and she's like a badass. So like she has like that like you see her and you're like, don't cross paths with me, like, so I really like that.
And you can also play your own role or someone else's role.
I would not do that. The movie would be very bad. Like it would go for a raspberry, so whatever it is. So I would let professionals handle it.
Excellent. We'll leave at that note. Georgia, thank you so much. If anyone wants to follow your research publicly, or be it on the Twitter sphere or X sphere, where can they find you?
Not on the Twitter and X sphere for obvious reasons. I've stopped using it. I've decided that it's they can reach me through my email. And we also host a lot of if you're close to the Los Angeles area and you love to visit the lab, we are actually having some sort of open like office hours and open houses. So we host
terrific.
often. where we talk about our research. I want us to get a little bit off the internet and more in person to learn a lot about this stuff. Also to mitigate a lot of the bias that comes through these social media platforms where technology is completely misrepresented. We need less people. We need less people to think that they know about things without knowing. And we need more people that are actually invested in a craft and want to learn more. And the way to do this is to come in touch with us and to get that information, in person.
Excellent. So to our listeners, check caltech.edu's website. One little plug, this podcast.
See somewhere, where is it? We're in Pasadena.
Yes, we are in Pasadena, just outside of Los Angeles. For if you watch The Big Bang Theory, that's where the magic took place, supposedly. This podcast will be on Apple Podcasts later today, Spotify by tomorrow. We do have a free course for professionals. It's called AI Tools for Everyone. It's a series of 8 hours teaching 8 different tools, starting with ChatGPT and ending in some of the coding platforms like Bolt.new and Cursor, and is absolutely free. Georgia, until next time, thank you so much for joining us.
Bye.
All right, bye.